Hi there, and welcome to this lesson on Pure Mathematics 3. And in this lesson, we'll be having a look at what are called natural logarithms. Now, what are logarithms? Well, the easiest way to understand logarithms is that they're the complete opposite of exponential functions. They're the inverse of exponential functions. We were looking at y equals e to the x in the last lesson. Now, the inverse function of y equals e to the x is y equals ln x. And sometimes that's read as ln x, sometimes it is just read as log x. The n stands for natural. These are sometimes called natural logarithms. The graph of ln x is the reflection of e to the x in the line y equals x, which is true for all inverse functions. If you want to draw the graph of an inverse function, you just reflect the original function in the line y equals x. So y equals e to the x looks something like that. If we draw the line y equals x, it goes diagonally like so. And then y equals ln x will be the reflection of this in that line. And as you can see, y equals ln x is an increasing function. It does get bigger and bigger and bigger as x increases. What this graph doesn't show very well is how slowly it increases. Exponential functions, they grow very, very quickly. It's the reason why you have the phrase exponential growth. It means very fast growth. Logarithmic growth would be the complete opposite. It would mean very, very slow growth. Now, as we said, logarithms are the inverse of exponential functions. Now, the consequence of that is that if you have the log of e to the x, the log and the e, because they're inverse to each other, they do just cancel each other out. So the log of e to the x equals x. So the log of e to the power of 2 would equal 2. The log of e to the power of 4 would equal 4. That's always true with inverse functions. Plus 2 and minus 2, they would cancel each other out. A squared and square root, they'd cancel each other out. The square root of 4 squared is just 4. That's always true with inverse functions, but it's very important with this type of question that you remember that, because you use it to solve equations. Equally, if we do them the other way around, e to the power of log x, again, because e and log are inverse functions, they cancel each other out, and that does just equal x. E to the power of log 3 would equal 3. Okay, using that knowledge, have a go at doing example 1 yourself. So solve these equations, find what x is equal to. Now, you're asked to give the exact value of the solution. Now, what that means is you don't write some sort of decimal for your answer. Write something like e squared or e to the power of 4 or log 3. That's what they mean by an exact value. Anyway, have a go yourself, pause the video, and then come back to me when you're ready. Okay, let's have a look at these. So the first question, e to the x equals 4. Now, as we were saying, the way we solve these is by using the inverse function. So we'll take the log of both sides, the log of the left-hand side and the log of the right-hand side. The log of the left-hand side will equal the log of e to the power of x, and the log of the right-hand side is the log of 4. So we've done the same thing to both sides of the equation. And the reason for doing that is that the log and the e cancel each other out because they're inverse functions. So the left-hand side just simplifies immediately to x equals log 4. And that is the answer. That's all they're looking for. You could look that up in the calculator, but you get an infinitely long decimal. So the exact answer is log 4. Second question, log x equals 6. Same idea, but this time we do it the other way around. We're going to do e to the power of both sides. So e to the power of the left-hand side and e to the power of the right-hand side. And that'll give us e to the power of log x on the left is equal to e to the power of 6 on the right-hand side. And again, the reason for doing this is that the e and the log, because they're inverse functions, they cancel each other out. The left-hand side simplifies to x, and that is the answer. X is equal to e to the power of 6. And that's the exact answer. That is all they're looking for. Now, question 2, it's the same idea. The questions are a little bit harder, but it is very much the same idea. The third question will require you to make a quadratic equation. So that one is a bit harder. But anyway, I'll let you have a go at doing these yourself first. So pause the video, have a go, and come back when you're ready. Okay, let's have a look at these together. So the first question, e to the power of 3x plus 5 is equal to 6. We do exactly the same as we did before. We'll take the log of both sides. So the log of the left-hand side would be that. The log of the right-hand side is the log of 6. The reason why we do that is because then the log and the e, they cancel each other out. And the left-hand side simplifies to 3x plus 5. And the right-hand side is just log 6. To solve the equation, we need to find x. From here on, it's just normal algebra. We'll move the 5 across, take it away, and we'll divide by the 3. And that gives us the answer. X equals a third log 6. Take away 5/3. The second question, don't be taken in by this. It's easier than it looks. You begin just by taking the plus 2 across to the other side in the normal way. And that gives you 3 log x equals 12. Then we divide by 3, and that gives us log x equals 4. Then we do the same as in the first example. We'll do e to the power of both sides. So the left-hand side becomes e to the power of log x, and the right-hand side becomes e to the power of 4. We do that because e and log cancel each other out, because they're inverse functions. So the left-hand side just simplifies to x, and the right-hand side is e to the 4. And that, again, is the answer in exact form. Now, this last question is a bit more tricky. We've got e to the power of 2x here, plus 3e to the power of 1x is equal to 10. First thing I do is just move the 10 to the other side. And this does have the form of a quadratic equation, but it's not immediately obvious that it does. So what you've got is e to the x squared plus 3 times e to the x minus 10 equals 0. You could use a substitution at this point if you wanted to. So some people would read that as y squared plus 3y minus 10 equals 0, then solve the equation for y, then substitute back in for e to the x. Or you can avoid doing that as long as you're comfortable with the algebra. This does factorize into 2 brackets, just like normal, and you get e to the x plus 5 in the one bracket and e to the x minus 2 in the other bracket. And if you multiplied those out, you would get this. Then we solve that in the normal way. So looking at the first bracket, that would give us the solution e to the x equals minus 5. Looking at the second bracket, that would give us the solution e to the x equals 2. Now, e to the x is always positive. If you remember when we drew it as a function, it's always above the x-axis. So it's never negative. It can never equal minus 5, which means there is only one answer. The answer must be that e to the x is equal to 2. The last thing we need to do is solve that equation. So if e to the x is equal to 2, then we take the log of both sides. So the log of e to the x will equal the log of 2. And then finally, the log and the e cancel out with each other, and that simplifies to x equals log 2. And that is the final answer. So that's the equation solved, x equals log 2. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 109 and have a go at exercise 5C. Thank you very much for listening, and cheerio.